In this episode, I'm going to look at a Harman Kardon hk505. This is a stereo amplifier, DC direct couple stereo amp. And we've got at least two, maybe three problems on this one. Well, there is actually three problems, and we're going to find them all. Let's check it out. Now, for you guys wondering, this is that deck number 2 that I worked on that had the bum display. I left it running overnight. As you can see, it is almost 100%. Everything's just one little dim segment here. If I tilt it up a bit, one little segment here. It's a little bit dimmer than the rest, but the rest of them have come back fully. Amazing, eh? That's what can happen with vacuum fluorescent displays. It can go bad and restore just from leaving them run. The vacuum tube is certainly starting to get weak, obviously, because that's why the emission was low to begin with. The tube itself is starting to get weak, but it's not shot. And just leaving it run, letting it sit warm overnight, left it turned on, it's fixed the problem. So let's get on to the next one. This time I've got a Harman Kardon hk505 twin-powered DC-coupled ultra-wideband integrated amplifier to check out. So let's plug it in and see what it's doing. See what it does. I don't hear any sound. That pop is also kind of unnerving. Almost sounds like there's some DC voltage going to the speakers. Okay, let's look around the back and see if there's any patch cords that are missing. Well, for one thing, something's loose, making noise. I got to plug main out and preamp out and main in, as there's no there's no patch cords on the back here. I'm on auxiliary 1. But it looks like I got to put the a patch cord in here between the main out and the input. So let's just shut it off first. And I'll get a patch cord and we'll put the jumper in. This is for like equalizer loop through. Okay, we'll try it again. Okay, I have one channel. So one of the channels is dead. Either that or the speakers aren't connected properly. Let's just make sure that left and right. It looks like they're connected. Well, that's weird. No, it's not weird. The shield, the tuner input, the shield on that cord for the red one is broken. It works when they're both plugged in because the ground is picked up from the other side. Plug it into tape 1. See if we get any sound through. Same thing, only one channel. But the fact that it's making all that noise when I tap it tells me that this unit has some problems with it. So let's take the top off it and see what's going on. So this is the unit itself. It's designed as like a dual monoblock, but both operating off the same transformer. It's got two separate power supplies here for the left and right channel, and then you've got the left channel board and the right channel board. obviously there's connections in here somewhere that's going bad because it's making crackling and popping sounds. And I only have one channel. Now even when I switch my inputs on the back, like the main out and inputs, so this is the main input. I can switch. This is the preamp. I'm switching it from one to the other. As you can hear, this side works and this side doesn't. So it's not a problem with the cable. It's a problem with the amplifier. And both preamp outputs work. So there's the right channel output, preamp, and here's the left channel output. When I turn this to left, now it's right, now it's left, and if I switch to this one, so the preamp is working. The problem is in the power amp over here somewhere. We have a failure on one of the amplifiers. So this is going to require a little bit more of an in-depth troubleshooting on this one to see what's going on, but we will get it working. Okay, let's first check to see whether we've got voltage. We know that this side is working. 42 volts on the case of one transistor, minus 42 on the other. Let's go over to this one here. We have 43 volts, and we have minus 43 on this one as well. So what I don't know is, am I not getting an input? It's almost like it's not, like I don't see any, there's no fuses or anything blown, but there's no sound. I'm curious as to perhaps it's got to do with interconnect below where the main input jacks go in. So I'll pull the bottom off this first and we'll look at the connections on the bottom before getting too far into it, because you never know. It could be something as simple as a broken connection on one of the plugs.
There, I called it a broken connection.
I mean, it could be something catastrophic on the amplifier board, but only one way to find out, and that's to trace the signal from the input. Make sure that the signal is getting to the amplifier board. If we look on the amplifier board, here are our inputs here. There's the green and the purple wire. One comes up here. This is the input to one board, and this is the input to the other board. So let's put the scope on, see if we have audio getting to the board. So I'm going to scope both inputs. I'll show you guys the scope. That's the input to the right channel that is working. So let's take a look at the scope. As you can see, the right channel's there, and this is the left channel. And if I switch it to left, you'll see that there is input. If you go to the right, there's nothing. So there's input going into the amplifier board, but I have no sound. So we know the fault is on the amplifier board. Now my outputs for the amplifiers, the green wire is speaker output, and oh, I think I just found the problem. I hadn't even scoped it. I was going to put the scope on here and measure if we had an output, but left channel. I do believe we have a bad connection. It's really that simple. Damn, I get lucky sometimes, don't I? I didn't even have to troubleshoot that. I had my input and I was going to check my outputs going to the speakers. And these are the speaker lines here, and this one here is obviously, it's cracked. How's this one look? That one looks okay. Let me just flip this thing over so we can see the other side. Now you would expect something like that to be made in China, but actually this one's made in Japan, and it looks like they just totally forgot to solder the speaker line. It is like how this thing's worked all this time. See, marked output. It's not. So how often does that happen where something out of the factory leaves and it doesn't get soldered? More often than you would think. We used to keep busy doing stuff like this, fixing stuff up like this when I was in the business. Things that weren't manufactured right. That's just a big oops. My iron's not quite up to temperature yet. So I'm going to have to get a new tip for this thing pretty soon. I should look and see if there's any other connections on here that look questionable while I've got it apart. But how do these other ones look? Well, those ones look okay, but I will redo them anyway. So I think that's probably all that's wrong with this. And see, that was a pretty simple fix. Put wire over here. I'll check the ones on the other side as well. Let's power this unit up again and see how it sounds now that it should be fully restored and working. The switches sound good. Not bad. This is my Akai. So the Akai I've got running into some PSB speakers. No bass or treble added, everything's flat, no loudness or anything. And I'll go to the Harman Kardon. Yeah, it's sounding good. Okay. It's going to be a bad connection on this board here. Listen. That one's okay. This one's going to have a connection on it too. So I have to investigate, see if we can spot a visual connection on this one. I didn't have to look very far to find an obvious bad connection right here on this transistor. Look at the leg right there. Right there. That one is cracked. I can see it from my vantage point here. I'm sure there's probably more than one on this board. I may have to pull this board out just so that I can see the rest of it. Now I'm probably going to have to pull the transistors out so that I can separate the heatsink from the board so that I can see what is what. So I'm going to mark the transistors. It's a 2SD675A on one side and a 2SB655 on the other. So I'm just going to mark the heatsink, which is the 2SD and which is the 2SB, so that they aren't accidentally reversed when it goes back together. It's always a good idea to mark them. So I'll just scratch a D onto this one, and I'll scratch a B onto that one. That way I know which transistors go with which set of outputs once I get them removed, as I have to pull the transistors out in order to separate the heatsink so that I can see the board and look for those bad connections. Now the heatsink will separate with the transistor still attached. Now I can actually remove them so that they don't fall out. Now I can inspect the board a little better and look for cold solder connections, because obviously something on this board is bad, besides the one that I can see right there. In addition to these, looks like these ones here are also bad down here. Look at them, they're cold connections. So I'm going to redo a few of these connections. There's actually several of them that look questionable, but this one here is by far the worst of them all. So I think once I redo these transistors, I'll do the drivers as well. But once I redo these ones, it should probably fix the problem. See, these ones down here also cracked. Probably wouldn't hurt to look at the other board while I'm at it, just for the other channel, just because if they're bad on one, there's a good chance that the other one's going to have some bad ones as well. But these transistors here, they're all cracked. These are in the preamp and in the phase splitter and so forth. And drivers. I haven't seen the others that look like they're in bad shape. Okay, I'll reassemble this side. We'll put some fresh heat sink compound on as well. All right, let's check this out and see if it's working, and then I will go and inspect the other channel, and we'll see how it looks. Aha, no noise. Good. Okay, I'm going to inspect the other side. We'll see how the other one looks, and probably do the same on it for the driver transistors, etc. I'm sure that if one side's bad, the other ones probably are just about as bad as these ones. I'll check the other side. I don't know if I'll show you guys me doing the work on the other side, just because it's just more of the same, right? But let's check it out and see. Yeah, on inspection, this one's got, look at that one there. Not even soldered down. So yeah, I got to pull the board out on this one and do this one as well. As I say, good thing I checked that. And check the other board. So we'll do this one. I don't think I'll bother filming this. All right, I got the board back in. Redid the drivers, the pre-drivers. All been resoldered now. We'll give this one a final test run and then put it back together and power on. Where's the delay? There we go. You notice when I'm touching the board, I'm not touching anything else. I'm not touching the metal knobs or chassis or anything. If I'm going to be putting my fingers around where there could be hazardous voltages, my other hand is away from anything that could complete a circuit. That's a repairman's rule number one. There we go. There, it's fixed. No more cutting out. Now I can put this one together with confidence that it won't be coming back anytime soon. There we go, this one's back together. Sounding good. Thanks for watching.